The Future of OpenTelemetry, OTEL. Welcome to our video on the history of OpenTelemetry, a pivotal project in modern observability. We'll explore its origins, key milestones, and its significant impact on the cloud-native ecosystem, providing a unified approach to telemetry data collection.
Before OpenTelemetry, developers relied on logs and metrics for system monitoring. Logs captured events through print statements, while metrics provided numerical data points like CPU usage. These tools offered insights, but were limited in complex distributed systems.
As systems grew more complex, traditional tools like logs and metrics became insufficient. Tracing emerged as a new approach, offering insights into request lifecycles across services, helping identify performance bottlenecks and errors in distributed systems.
Google's Dapper, introduced in 2010, pioneered distributed tracing. It introduced concepts like Trace ID and spans, laying the groundwork for open-source tracing systems. Dapper's influence led to the development of projects like OpenTracing.
OpenTracing, launched in 2016, provided a standard API for distributed tracing, allowing developers to instrument applications in a vendor-neutral way. This enabled organizations to switch tracing backends without altering their application instrumentation.
While OpenTracing focused on traces, OpenCensus aimed to unify metrics and tracing. Originating from Google, OpenCensus provided libraries for both, offering a more comprehensive observability solution, though its scope was still limited.
By 2019, the need for a unified observability solution led to the merging of OpenTracing and OpenCensus into OpenTelemetry. This new project aimed to provide a single set of APIs for metrics, traces, and logs, ensuring vendor neutrality and ease of use.
OpenTelemetry's development began with building core API and SDK for traces and metrics. By the end of 2020, Tracing API reached stability, marking a major milestone and allowing confident use of OpenTelemetry for tracing in production environments.
From 2021 to 2022, OpenTelemetry expanded to include metrics and logs. The stable metrics specification allowed unified instrumentation for traces and metrics, while efforts continued to integrate logs for a seamless observability experience. As OpenTelemetry matured, it gained widespread adoption. Major cloud providers like Google Cloud, AWS, and Microsoft Azure integrated OTEL support, and observability vendors embraced it as a core part of their data collection strategies.
OpenTelemetry became a key project in the Cloud-Native Computing Foundation, reaching graduation status in August 2023. Its integration with Kubernetes and Prometheus made it a standard choice for observing cloud-native applications.
Recent developments in OpenTelemetry focused on logs, aiming to provide structured logging capabilities. This progress allowed better integration with existing log management systems, enhancing the overall observability experience.
OpenTelemetry's architecture includes language-specific API and SDK for instrumenting applications. These tools support traces, metrics, and logs, providing developers with a comprehensive framework for observability across various programming languages.
Auto-instrumentation is a key feature of OpenTelemetry, automatically detecting common frameworks and capturing telemetry data. This reduces the need for manual changes, simplifying the process of instrumenting applications for observability.
The OpenTelemetry collector is a crucial component, responsible for receiving, processing, and exporting telemetry data. It can be deployed as an agent on a host or as a centralized service within a cluster, offering flexibility in data management.
OpenTelemetry's vendor-neutral approach ensures that developers can use the same instrumentation regardless of their choice of backend. This flexibility supports a wide range of observability platforms, from open-source solutions to commercial offerings. The governance model of OpenTelemetry involves collaboration between many companies and individuals, ensuring it remains community-driven. This model supports continuous evolution and alignment with the needs of developers and operators.
OpenTelemetry's wide ecosystem support includes major industry players like Google, Microsoft, and Amazon. This broad backing has contributed to its rapid adoption and integration into various cloud and observability platforms.
The project's focus on ease of use is evident in its comprehensive libraries and SDKs, which minimize friction in adopting observability. OpenTelemetry's auto-instrumentation and language support make it accessible to developers worldwide.
OpenTelemetry's impact on the cloud-native ecosystem is significant, providing a unified observability solution. Its integration with popular tools like Kubernetes and Prometheus has made it an essential component for modern application monitoring.
The evolution of OpenTelemetry reflects the industry's shift towards more comprehensive observability solutions. By unifying metrics, traces, and logs, it addresses the growing complexity of distributed systems and cloud-native architectures.
OpenTelemetry continues to evolve, with ongoing efforts to enhance its capabilities and expand its ecosystem. Its commitment to vendor neutrality and community-driven development ensures it remains a leading observability solution.
Thank you for joining us on this journey through the history and evolution of OpenTelemetry. We hope this video has provided valuable insights into its development and impact on modern observability practices.